All right, hey everybody. Just going to go ahead and go over distributive property. So we're looking at this handout to kind of give us some examples that we can demonstrate for you. Simplify the following expressions by following the orders of operations. Okay, so order of operations means you would do what's inside the parentheses first. So I would go ahead and take the 3 and the 9, and I would add them together. So 3 plus 9 is 12. Okay, and then parentheses I'm still going to keep because in this case they actually mean to multiply with the number that's outside of the parentheses. So it would be 6 times 12, which gives us the answer of 72. Right now we're just simplifying, so they're not actually looking for us to give the answer. Okay, so we're going to leave it at that. Basically, the other way I could do this is if I was using the distributive property, I could go ahead and take the 6 from outside and multiply it times the 3, and then again take that 6 and multiply it times the 9 on the inside. So I would end up with two different multiplication problems, 6 times 3, and then I would add that to 6 times 9. Okay. And then once I got done with those two answers, I would add them together because in order of operations, we would do multiplication before we did addition. Okay. And again, this is still going to give us 18 plus 54, which adds up to 72. Okay. So just giving you another example, ways to make this problem easier, potentially using some more mental math. Okay. So down here on this bottom spot, the distributive property allows the number on the outside, that goes right there, of the parentheses to be distributed to the terms inside the parentheses. Okay, so they're giving examples, of course, on how that would happen. Okay. A scenario that we could use here, those Robinsons again, that went to the county fair and bought pizza, sodas, and ice cream cones. Okay, well, now they're telling us there are 4 of them. And since all 4 of them ordered the same thing, right, they simplified their expression to make it easier. Okay, we know each one of them is getting a soda, 2 slices of pizza, and a cone. So then when I go ahead to distribute this, I would be 4 times the sodas. Okay, so when I wrote this, it would be 4 drinks. It would be 4 times 2 slices of pizza. Okay, so 4 times 2, okay, which actually equals 8 pieces, right? We have 4 times 2. And then 4 times 1 cone each. So we would end up having 4 cones. So taking that distributive property and distributing the number that's on the outside, in this case 4 family members, to each of the terms on the inside of the parentheses. Okay. It also works in the area model that's shown here. So we would multiply the number on the side, this 5, that constant, times the term 3x, right, which would give us 15x, and then 5 times the 2 that's over there, which would actually give us 10. So it's basically the same idea. They're just giving it to you in a different format. And this can work even if we have terms that have a coefficient. So another example on number 4, I'm going to go ahead and show. We could do 5, distributing that to all the parts inside. 5 times 6x, which would be 30x. And then the second part of that would be 5 times 9, which is going to give us 45. And just like before, when I was talking about paying attention to constants and coefficients, okay, we still have that. This is, in fact, a positive 3k, okay? And then we also have our negative 2 in there. So when I am distributing, I'm distributing that positive 4 to a positive 3k to get 12k. And then I'm going to distribute that 4 to the negative 2 and end up with a negative 8, because a positive 4 times a negative 2 is going to equal a negative 8. Okay, and again, just to show exactly what that problem looked like, it would be 4 times 3k, and then I would also have 4 times negative 2. Okay, sorry for adding in that extra sign there. Okay, 4 times negative 2. And I would just be combining the first problem with the second problem so that I end up with a simplified expression. Okay, hope that helps. And we'll also mention that while a lot of times you're going to be presented with problems set up with a distributive property, you can do factoring an expression, which is basically working it in reverse. Okay, so when we are factoring an expression, the expressions can be factored, and that's that first blank line right there, okay, to remove the common factor, which is how we undo the distributive property. Okay, and we've talked a lot about undoing or doing the inverse operations with this. So we'll do a quick little example of that as well to hopefully let that sink in. And then I would strongly recommend going and practicing some IXL lessons that have the distributive property in there. Okay, so if I have 6a and a positive 2, I'm looking for factors that could come out of that. Well, when I see the number 6 and 2, I know I could divide them both by 2. So if I pulled out the 2, okay, then I would divide 6 by 2 and get 3. So inside the parentheses, I would have a 3a, right? I still have that coefficient with that variable a. And 2 divided by 2 equals 1. So now I have 2 times 3a plus 1. And this is my expression. And again, like I said, more often than not, you are going to work from a distributive property problem into a simplified version. But on occasion, you will be asked to do some factoring of an expression and turn it back into a distributive property by pulling out the factor.